Hey guys, sorry for the delay, but I think we've got it figured out now. Um, how many people are we right now?
Six. I guess let's wait a little bit for.
Yeah, 6 people. You can see it in the bottom right corner.
Oh yeah, yeah. I think let's wait for like 2 more minutes and see if someone comes in.
Cool, let me try and share my screen in the meantime.
Sure.
Oh, it's very good to hear your voice. It's back to normal.
Yeah, almost. Like I'm still not fully recovered, but it's getting better. Gonna just mute myself whenever I need to cough.
Can you guys see it?
Yep.
Oh, sweet. Is anyone going to Amsterdam for the hackathon? Nice.
I might be going as well, but I'm not a dev, so
It's still fun.
yeah, for sure.
I wonder, I'm there for the weekend. Is any idea, like, it seems like there's like an applied ZK workshop. I don't know if that's gonna be interesting. Anything about the weekend programming? Or are you just going for the hackathon?
I'm going for several events. I remember that particular one, but I don't remember exactly when it was. I have some events that I have to attend, so if it conflicts, I won't be able to. But that's one of the ones I had on the short list.
Yeah, nice. Hopefully it's not gonna be as packed as Denver was.
Okay, I shared the link in the Discord again. Let's hope let's maybe do until 5 p.m. 10 minutes, so 2 more minutes, and then we can start.
So good.
All right. So I'd just like to say a few words initially. First of all, thank you to Peteris and YagiFi for organizing this and presenting. I think it's a very good medium, these kind of workshops, to dive deeper into specific topics, which might be a good avenue for MatchboxDAO to pursue in the future, so we can like get specific insights into specific things. And I think it could be a really great way to achieve that. And yeah, without further ado, I'd like to give Peteris the stage.
Thanks. Yeah, great to do this. Been super excited to see kind of the momentum around Matchbox and like the crazy ideas some of you guys have. So I thought, no better place to actually talk about automation in here. This is, I think, where some of the, most of the innovation is happening on the gaming front here. So yeah, great to be here. Yeah, so kind of before I start, maybe I'll start a brief introduction myself. Yagi's pretty recent. Kind of to give you a sense of that, I started learning Cairo over Christmas, and so in kind of in the interim, been able to kind of launch the first version on testnet, and kind of we'll talk in detail about what that means. Before that, I've sort of been in the blockchain space for about 3 years now. Initially working on a lot of developer tools and security tooling, built sort of EVM clients, formal verification tools. Things like that, kind of mostly consulting basis, and then started getting more into smart contract development, and then kind of recently came across Darknet and actually started working on a protocol finally. It's about time. So before that, was an engineer and a consultant, worked Google, Twitter, McKinsey, main places I worked at. So yeah, objectives for today, basically 3 objectives. So first, let's just kind of discuss and frame the role of automation in game development where it can help. 2, I'll briefly talk about Yagi and kind of how specifically we implement automation. And then 3, mainly would love to just brainstorm kind of ideas of like how automation could be applied in gaming. I think I have a couple ideas that I've heard already from some people here, but I think we can probably expand the landscape quite a bit. And sort of I'll share a couple of ideas on maybe how to try and think about game state in general, and how that can lead to deciding to or not deciding to use keepers for certain use cases. Cool. So basically, why should you use automation? So there's effectively 3 types of transaction you can have in games. 1, you can have player transactions initiated by players. Those are going to be the most common. 2, you can have game admin transactions. So, these are kind of game developers like yourselves, basically, deploying the game, things like that. And then the 3rd type is keeper transactions, which, allows kind of a decentralized network of robots kind of call your contract on a kind of pre-specified schedule. And that's kind of what we're going to be exploring today. Player actions should really do most of the lifting. What are player actions? So common ones I've seen are decision making, turn-based game moves. Solve to min project is a great example of that. Financial transactions. If you have kind of a financial style game like Dope Wars, where you have resources and trading and so on, a lot of those are financial transactions. And then of course, on-chain state settlement. So if there is sort of an off-chain game component, I think Gods Unchained maybe being one example of that. You can kind of settle game results and things like that on chain. So kind of those are common things that may be player initiated. Game admin transactions. So those are ways to do kind of more complicated game state updates that need some sort of admin authority. Transaction types would be tournament or game deployment, initiation. You need someone to deploy the game. Usually is the admin. You need, if there's bug fixes or patches to the game, that's probably an admin upgrade as well, and game parameter updates and things like that. However, the challenge with admin updates is they're centralized, they're irregular, like you don't want to be doing them sort of every hour. You can't really, waste developer time that way. So we definitely want to try and shift as much as possible, kind of away from game admin updates as possible to make the game truly decentralized, right? And to encapsulate as much as possible into the game logic itself. So what is a keeper transaction? Well, the idea of a keeper transaction is it's automated. It's defined by the game contract itself. There's no player interaction required to initiate a transaction. There's no admin interaction required to initiate a transaction. The game contract itself specifies when the transaction is going to be issued and what's going to happen. characteristics there are, the logic is fully encoded in contract, it's decentralized, because you have sort of a reliable network of bots that are going to call your transaction. It's reliable, and it's actually secure. I mean, it's not secure kind of by guarantee of the Keeper network. It's secure because the way you should design Keeper transactions is with very limited permissions. A good check is basically if the transaction should be callable by anybody, and that should be fine. So you could using the Keeper network is really a way to guarantee that the transaction will be called. Well, you shouldn't, for example, expose admin rights and so on to keepers. You don't really want to do that. A good example of this are, for example, investment vaults where they have these kind of harvest transactions, and you could think of a harvest transaction as something that anybody could do, but nobody wants to do, and therefore you can use a Keeper network to basically initiate it at a certain regular time. And the contract should have all the logic of preventing it to be called outside a time window, or with bad arguments or whatever. Any questions on that concept so far? Or Keeper transaction? Cool. All right. So how does it work today? So today on testnet, we have a live version. It's very, very simple. You have your game contract. You define those two things, when it should be called, what should be called, and then the keepers will call the contract autonomously. There's no fees involved because everything's free on Starknet so far. That will evolve in the future. Obviously, once fees are turned on, and keepers will have to pay for gas fees, keepers will be looking for some compensation. So for that scenario, we're building kind of the next version of Yagi, which will have a keeper registry. This keeper registry will then, allow task authors to basically, submit these tasks and set up some sort of budget, out of which the keepers will be compensated. And actually, the task author will also have full control over how much to pay keepers per given transaction, and also in what token to pay with. Some of you'll know that there's actually going to be kind of two payment methods. One is you can have this budget, and then the keeper will get paid automatically, set by the registry from the budget. Or you can actually define the payment in the contract itself. So if you want the game, maybe the game has some sort of game token and you want to just pull out of that, that's also fine too. Both kind of methods will be supported. And at the end of the day, it will be, capped by whatever kind of you define in smart contracts. Any questions on this part? Cool. Okay. So practically, how does that look? Basically, you have these two functions. Probe task basically allows you to check if the task is ready for execution. Execute task is the thing that will be called by the keeper to execute the task, right? So probe task should return basically true or false, or aka 1 or 0 in felt form, and then execute task can do whatever you need to do. And then quick note here that execute task should also usually should call probe task as well if you don't want it to be called in arbitrary time. If you don't mind execute task being called in arbitrary time, that's fine. But usually you should assume that execute task can be permissionlessly called and protected from, just make it revert if you don't want it to be called. That's it. That's basically all I need to do. So the only second step there is to just ping us and make sure we add the contract to the registry. The reason we need to do that right now is so that we can configure the bots to basically, call it at the right time. So whatever the frequency is or that you want it to be called, we can make some tweaks for the keeper kind of client to make sure it gets called, at that specific frequency. Yeah, that's about it. Kind of specific example of that, we have a counterexample contract in the documentation. This is what we're seeing here. Probe task, for example, could see it could have a state variable remembering the last execution, and then 60 seconds pass. We can just check that, okay, we can execute again after 60 seconds, right? So this contract would effectively work as a sort of a timer in terms of probe task. And then we could, here we have a counter. We basically want to count how many minutes have passed. So every time the task gets executed, we'll just increment that counter here. So pretty simple. That's really all you need to do. And then sort of the keepers will kind of take care of calling probe task and execute task. Not to go into the weeds too much, but basically the keeper will call probe task as a call, and then it will call execute task as an invocation. if probe task returns 1. Cool. Clear so far on how to use it? Great. Okay, cool. We'll get into the good stuff. So, yeah, so we have a overview of tasks right now on the, we have a dashboard up. So that's a way of seeing like what tasks are submitted. And feel free if you actually want to create an automation or experiment with an automation, feel free to involve us. Just ping me on Discord or Twitter, and I'd be happy to help with even writing some Cairo code and so on. So yeah, definitely eager to help people out with writing automations. Also, we'll be in Amsterdam, so if you catch me there, happy to chat and brainstorm how to use automation as well. So
I have a small question. So basically, your future plans is to enable, let's say, games or any application that needs both gas and automation of other functions. For example, like if there is a game that needs to approve his users to approve like every action, he can create some kind of functionality in Yagi that will make it like seamless for his like the game user in that case.
Yeah, I mean, I love this question, first of all, because you've basically kind of led us into the third section. Like literally the third section is about kind of how to use it in gaming, but essentially, yeah. So it's a way, it's a way for the contract to define, I want to be called in a certain way. I will pay, I have the money to pay the gas fees that are required to make that call, and then, sort of set it and forget it, right? You don't need any admin to run that transaction or any player. It will just happen on whatever kind of schedule or trigger you want, right? It doesn't even have to be a schedule. It could actually be some sort of sophisticated trigger in your game state, which says, oh, now we should call the upkeep transaction or the rebase transaction or the so the probe function can pretty much be anything, right? I think the one thing that probably would be very annoying for the probe transaction to be kind of, I don't know, very random based on blocks where like it goes on and off, but those use cases are pretty rare. So yeah, pretty much anything you can get away with. But yeah, I'll dive into specific, I think, and I'll need your help, everyone in the call, to kind of figure out what the best use cases are for gaming, but have some starting ideas that I've already collected in the course of kind of seeing people think about this. So the first important thing, though, I don't want to oversell automation. I think it has a place, but it's also important to remember just how much we can do without automation in specifically, Cairo development, smart contract, game development. And most importantly, I think there's this sort of clever idea of server client-side rendering that I think Guilty Gyoza will be very familiar with because he's kind of building everything around that, which works really well without automation. So, and specifically, that is kind of if you want to read more about it in terms of traditional game design, the kind of Valve kind of use this quite a bit with Counter-Strike and some of their earlier games, of this idea that you have a server that's kind of running at a certain frame rate, and then your client is running at another frame rate, and then the client sometimes when it doesn't get enough frames from the server, it's sort of able to figure out like where people would be because it does interpolation. So like let's say it knows that the character started here and then it started moving in a certain direction. If it doesn't get frames from the server or some frames are dropped, the client side, on your computer will kind of know, well, the character started moving in this direction. Let's just assume they keep moving there, right? So if anyone's played Counter-Strike, you know that sometimes the characters just kind of keep moving, and that's because you have kind of client-side interpolation happening. And sort of on blockchain, games that have some evolution over time, can take advantage beautifully of this technique, right? Dark Forest is built around this technique. A lot of Guilty Gear demos are built around this technique of, and please correct me if I'm wrong, but basically having the state updates basically just based on kind of player moves, but then having this notion of yeah, that could also be the case, Araki. But in the front end, sort of being able to interpolate, right? In the front end, we could always say, oh, what if the block timestamp was this? Then we think this is how the field should look like, right? Yeah, we'll cover limitations of when this doesn't work anymore. But generally, you should try to use this with not automation if you can, and use it as much as possible because it's a fantastic technique. But okay, where can you use automation? So first idea was from Loris. You could do a timer, right? So if we want to try and replicate game timers that exist in traditional games, we can do it using automation very easily. I think one area where it can be useful is, let's say you have a game and you want to, for example, know, what the price of a certain thing is at that point in time in Dope Wars, and you want to have some sort of state update that is based on that external state. Then the kind of client server-side rendering technique completely breaks down, because there's no way you can predict that price, right? So you need to actually know it. So if you need to incorporate some external state from some external game, at a regular cadence in your own game, that's when you can use timers using automation, right? And so, for example, you could set it up to be every minute, every day, every couple of seconds, kind of whatever you want. I guess we'll see, we'll see how quickly the Starknet network scales. Right now, probably not every couple of seconds, but I'm sure we'll get there. But yeah, so that's kind of one place where timers actually can make sense. Another use case, and this is actually happening on layer 1 right now, is player farming. So automation is not just used by game developers themselves. Sometimes players want to use automation as well to automate certain actions that they do with your game. And so if you know Abegachi, you have this notion that you have to pet them every day or every 12 hours, and it can be quite annoying to do that. And so people build kind of automations where you can just kind of put your Abegachi in gachi care or daycare, and basically it will be petted kind of at the regular interval. But this can get much more sophisticated, right? Again, with a game like Dope Wars, we could actually build entire investment strategies or farming strategies around this theme. So definitely be aware, whether you do or do not want to support this directly in your game, just be aware that players may actually try to build these automations. But it also can be a nice kind of meta game if you do want to support it natively and do want to create those kind of additional modules that support some kind of automation as well. Okay, so next one is scheduling tedious admin actions, right? So if you, for example, look, certain admin actions maybe are expensive for users. So let's pick one example, which is tournaments. If you want to schedule kind of a daily tournament for your game, where the tournament started, people are invited to play, there's some sort of like Swiss system that's formed, and people end up sort of playing each other with the tournament. You could, in principle, set it up so that the tournament is created by the first player, who kind of wants to join the tournament at a certain point in time. However, that player will be kind of paying for all the state setup that's required for the tournament, right? So if there's a lot of state setup to kind of build up this tournament, you don't want that first player to have to kind of pay for it all, because very often then it basically will need an admin to come in. So instead, you could just set up a automation that kind of creates that tournament at a regular interval. And similarly, for maybe asset minting or NFT minting, you could be doing it also for parameter updates for a game, things like that. Okay, cool. So then an idea from Guilty Goza is to run suspended computations. There's this idea that we have the step limitation in Cairo right now. We may have limitations on just how much complex logic we may pack in a transaction. And so with automation, we could run, we could suspend our transactions, right, or computations basically, and run them over multiple transactions, right? So let's say we have a transaction that's we could run over 3 different transactions, right? It's a very complex computation. We could have a way to basically, run the first step and then set it up so that the keeper is basically asked to initiate another transaction and run the second step, and then do that and ask the keeper to do a third step, boom, and then it's kind of finished. So yeah, this is kind of theoretical at this point, but could be interesting if we push the limits that far. Cool. Actually, Guilty Goes are curious, like, have you run into this issue yet, where have you pushed against a step limit yet, or?
Yeah, I guess all the time. I guess my sort of game contract, a huge focus of my game contract is exactly dealing with the step limit. So I would exhaustively test different kinds of initial conditions in my physical systems, and I will make sure that even with the most complex scenario, simulating the entire run will stay within one transaction. and I would just use that sort of level of complexity for my game.
Yeah.
Yeah. Yeah. That I obviously see this as very useful.
Awesome. Yeah, that makes sense. Yeah, I think if we had a nice way to kind of, figure out, it would be nice if we had some sort of metering where we could like say in the transaction itself have some sort of hook when it like runs over certain steps. But yeah, I mean, I guess you're already building up some understanding of like how to predict that. So
Let's have a meter, definitely. Let's have I'm hoping to get a gas left function entirely.
yes, yeah, yeah. One can hope. So okay, cool. Another crazy idea. So, oh, sorry, Discord. It is. It's off. Yep. So game AIs, right? So we could, we could imagine, or thanks for pointing out. We could imagine like having a game with multiple players interacting, kind of walking around a landscape, or maybe collecting resources and so on. You know, it would be nice to have some sort of automated NPCs there. And again, like it comes back to the point I made earlier. If you can kind of entirely predict what the NPCs are going to do in a fairly automated way, you probably don't need to automate the NPCs separately. But if you want really sophisticated NPCs that maybe, again, look at off-chain state, or they maybe generate some random values or use VRF or something like that, then actually you could, automate these NPCs using Yagi. You could basically, again, like set some sort of frame rate at which the NPCs do their interactions, and then have them kind of moving around along with the players. And I could also assume that players will develop their own, NPCs over time as well. For certain games, maybe to automate their own kind of farming. So it could be seen as an extension of that. Cool. So then I kind of try to kind of step back and come up with some sort of thinking. Game NPCs own liquidity themselves and pay for their Yagi transactions. Yeah, I mean, it's not even that far fetched, right? You could definitely see. I mean, certainly players could build NPCs like that. I think it definitely will happen if the games have enough economic merit to do that. And so yeah. So try to come up with certain. I think this is very early thoughts, but basically, I think kind of when you ask yourself the question like, how do you decide what should be an automation or not? I think one way to think about it is to think about game state and how to factor game state. And so you kind of have these three types of transactions, and ultimately what you need to figure out is like, what parts of your state, you only want the admin to update, and those are going to be admin transactions. What parts of your state you can get the player to update, and those are going to be player transactions, and sort of everything else will be keeper updatable state, right? And kind of this chart kind of illustrates basically, ultimately the keepers will call into two types of things. One, they will call in your game logic the keeper updatable state and update that. And then two, they probably will call into some farming tools that the players will deploy, which will end up as player transactions in your game contract as well. So kind of one way to see the landscape. But then, of course, it's interesting, like, okay, well, how do we actually decide what goes into the player updatable state versus the keeper updatable state, right? Probably usually the decision points there. So I try to come up with a sort of flow chart, but this probably is missing a lot of use cases. But let me kind of follow from the top. I think first question is basically, are state updates too big for one transaction? If so, you can use the suspended computation idea, right? Now, if your state updates are kind of enough to fit in one transaction, then I think it's interesting to ask, does the state evolve over time, right? If the state evolves over time, then there could be a keeper application there. But it's also, there's kind of a sub question there, which is, does the state also depend on external games and other contracts, right? If the answer is yes, we already discussed, we probably need a keeper, right? So we can get basically get a regular input of the state. Think of it as almost like an oracle, where you're using the automation as an oracle to kind of regularly pull in external data from other games and update your game state. The other question could be, is there some global state that's too expensive for individual users to pay for, right? So again, kind of going back to the tournament example, like you could trigger the tournament on demand, based on the first player, right, who signs up for the tournament, even before the tournament exists. But in some cases, you can see it as unfair. You don't want the first player to be kind of paying for that expensive transaction that sets up all this game state. You kind of want the players just to pay for the sign up, and then have the contract, pay for that complex logic. I think hopefully We may get other solutions to this. We may get a some sort of kind of gas station type solution which allows us to capture gas in the contract and maybe absorb some of that, or maybe give a player kind of gas refund. So there could be other solutions to this, I think. But right now could be an elegant option to just have that running on automation. And so on the other branch, if it doesn't evolve over time, I think then usually I think you may not need a keeper. It just depends on can you encode these game state changes ahead of time? If you can, it's a player transaction. If you cannot, it's an admin transaction. But yeah, these are kind of very early thoughts. So yeah, I mean, hopefully this has given you some kind of high-level understanding, but I'd love to spend the next time and basically answer your questions and start brainstorming like other kind of crazy ideas and applications and how this may fit into kind of your games and actually what maybe kind of more concrete question is like, is there something that we could build for Matchbox, right, to support this primitive or kind of make it more useful.
I've got some questions and remarks. Thanks a lot for the presentation. So I'm still building a brick on StarkNet. First question, it might be a bit naive. I just want to understand the difference. I'm fairly familiar with how Gelato network works on L1. How do you differ, and how do you differ from this?
Yeah, so the design is actually pretty similar to Gelato. I think the main difference is going to be just adapting StarkNet differences. So, and I think it's a bit simpler right now in the sense that there's no token model involved at this stage. I think the main StarkNet difference is that the way Gelato works is they have gas metering on Ethereum mainnet and some of these other networks. So they have a gaslit opcode. They're able to basically set a margin. So for example, you run a keeper transaction, they can say, oh, if the gas ends up being $5, then it'll be like a 20% premium on top of that. And then that's what the contract will pay. On StarkNet, we cannot really do that at this point, at least. So we're going to have a kind of bid system where basically the task author is just going to say, I'm going to pay this much. And then the keeper is going to basically, get paid kind of that amount, irrespective of what they end up paying for gas, basically behind the scenes. Just because we don't have gas, maybe we don't have a way to encode that in the contract. But other than that, obviously the keeper bot is using StarkNet tools and so on behind the scenes rather than Ethereum tools. But kind of conceptually, the basic idea of having like two functions that check state and execute state is kind of same as Gelato or Keeper or Chainlink keepers, right? Funny enough, I'm actually talking to Gelato tomorrow. Before mention of the guys, but yeah, very similar, just with starting differences.
Get it. Well, one side question I had, like I saw that Gelato got hacked recently. I'm not sure I understood why that happened. So do you have an idea of what exactly could be the I would say the vulnerabilities of such a network? One thing I could have in mind is, since you're incentivizing people to run transactions, sometimes they can have adversary incentives not to run a transaction, which I wouldn't qualify this as MEV, but maybe something similar to this.
Yes, yeah, exactly. No, you're right. That is a big issue, right? So imagine a network where you have a small number of keepers, and let's say you're running some sort of, this happens more often in DeFi, right? Where if like a keeper is rebalancing a vault, then the keeper may actually, be some sort of asset holder, and they may think, oh, interesting, like I could atomically, rebalance the vault, but in that same transaction, I could like front run it, for example, and like buy the asset that's getting rebalanced into, right, and like hurt the team that's actually doing it. So yeah, so that's definitely a vector. I think the way you have to mitigate against it is just how you curate the keepers, and also how you kind of end up monetizing. I think some of these networks maintain a very small number of keepers, and they become one of the keepers themselves for monetization purposes. I think that's something that we want to avoid. I'd rather have a larger set of keepers and monetize maybe through a small protocol fee, but not actually have a reliable kind of broad set of keepers. I've also done some research on reputation systems, and there's a way to kind of build those in as well, where you can, Keeper has this model where you can, as a task author, say, well, if my thing is sensitive, like I only want it to be called by keepers who have like been in the network for like 6 months or something like that. So another way to like mitigate that, and we may enable that in the future on request. But honestly, I think it's going to be driven by the use cases. If we see a use case where we think it's sensitive, we're probably going to work together with the whoever's alternating that use case to figure out a way to make sure that there's no MEB.
Yeah, I was wondering exactly how that worked out for Gelato. I guess you could also implement some sort of slashing mechanism, like a keeper would have to put down some money, and if they don't follow up on a contract, if they, it's a bit like service level agreements, but
Yeah,
it's not
I like it.
Sorry, I'm just bombarding you with questions. So another one I had was more regarding more. So I completely agree with you on the DeFi stuff and automation. I mean, that's a super interesting primitive. I had more like a maybe global question, and that's probably more for the Matchbox folks regarding automation happening on chain. So here, I really love your diagram. I think it really explains how we should do it if we want to do it on chain. I'm trying to think if we're not being, and I had that term, too skeuomorphic, and actually trying to replicate the entire game state on chain. So I was thinking of something in it, and that's maybe a bit of an alternate solution, which would use something called Vidu, like a time prover. I think it's time elapsed stuff. So you just prove that something took time. So rather than having a ticker on chain, you would just have a smart contract that verifies that an action can only be performed at certain intervals. So rather than having the state on chain and having the ticker on chain, everyone has the same clock, but you're just verifying on chain that you can actually do it. I'm not sure if I'm making much sense.
I didn't follow fully. It sounds super interesting. So tell me more. So does it involve the prover at all, or is it? Do you think we can do it kind of what we have now, just purely with smart contract logic?
I think we could do it with just pure smart contract logic. Like if what we want is to synchronize everyone on the same tick.
Yep.
Like one option is just to have the tick on chain. That's what Louis said on Matchbox.
Yep.
Maybe what we could have is like like a clock. Like every single web browser running the game has an internal clock, and you're using Vidu to verify that each of these browsers is performing some kind of calculation for time elapsed, that you're sure that no one is ahead of time.
Oh, I see what you mean. So you're relying on like certain option computations, right? And then you're making proofs about kind of they use time, right? And that they
exactly.
Okay. That's super interesting.
Yeah. Maybe like mining, just to prove that you spent time doing something. So it's probably not necessarily super usable, at least for a game. But I was wondering if there was like another model that we could use for like clock synchronization or tick. And I wonder if this is something that we could apply.
Yeah, I'll have to look into that. I mean, this is super interesting. I guess you could definitely guarantee that you basically did it like later than X, right? You couldn't necessarily guarantee you did it earlier than Y, but you could at least do it, but like you spent the time, right?
Exactly. That would definitely make sense. Like there's a conversation on a chat on Matchbox, which is about like building Minecraft. So if you want to make sure that someone has spent 10 minutes mining something, you definitely use something like this.
Yeah, that's cool.
It's definitely super, like this is going to be extremely useful. I do expect this to be a lot more, like Yagi in general, a lot more useful on L2s than it is on L1, just because like this whole like dead capital of transactions that can't be run on L1 because it's prohibitive. But now that it's actually becoming a lot less expensive, we're going to have a lot more cron job type of transactions that have to be performed. So it's super cool. I think this is going to be a lot more useful than it is on L1. Viewers are dripping with alpha in the chat.
So
just go ahead.
No, go for it.
I was just cramming the channel here. So yeah, two things. High level. First, I think we can have a variety of orders, and second, I think that Yagi seems to me really like an OS feature. So I think one day we'll have a Yagi just incorporated in the rollup itself. Right now, it's sort of like a smart contract protocol. Accounts dealing with the participating in the protocol. I think eventually we'll have a rollup where the participants of the rollup itself, maybe it's proven, are incentivized or even required for incentive purposes to basically mother all smart contracts with a certain need, right? Regular needs. Yeah, but going back to the first one, because I think the second one is pretty long term. Stark would definitely not see this as a priority, so this will not happen in at least a year. First thing, I think, order book, right? So I imagine many games will have to get regularly called of certain functions, so we can outsource, sort of refactor that timing calculation into Yagi and just ask apps to post an order of a particular type, say call my function every n seconds from now on until I cancel the order, and then I can later submit an order, say I cancel my previous order. Kind of like order book, but it's not exactly order.
Oh, geez, that is so cool.
I think there's a neural network that actually has this. It's that reminds me of Superfluid, like the streaming payment thing.
Yeah, because I think the polling mechanism is one way. It's definitely not the most efficient way.
I like it. So the idea is like the smart contract itself could just issue an order where it, instead of defining the function for itself, it kind of encodes it in the call data of, of the order, right? In the order struct, basically says like, yeah, this is the function needs to be called. This is the trigger for it to be called or whatever. Especially if it's like a timing thing, right? If it's not like much more complex than that.
Yes, definitely. So if it's a timing thing, we can do before after. Right? Before, it's a time, and I maintain my own timing, and I would basically switch on the LED, so that when you come look at my LED, you will know that okay, it's your turn to call my function, right? So there will be many sort of unnecessary transactions just coming back and pull LED again and again. Whereas after having this order, I will register an interval of n, and you will maintain the timer, and you will come back after n. So that's one transaction per period.
That's super smart. That's I had something in mind, but I didn't put it as eloquently as you did with the keep a network and transactions piggybacking to reduce the cost. It's super cool. That's a really good idea.
I still think that this is really an OS feature. This is really like task scheduling, where each task has a need. I need to be triggered. I'll send you an interrupt when I'm done, etc., etc. So yeah.
But I like that mental model, right? Of like an OS feature, and then it leads you to sort of this idea of like an event. You're basically talking like, okay, so then we need some sort of event queue, right? Basically, and so you're then driving the order book from that. I think that makes sense. There's probably other interesting applications of that idea. But yeah, I think the order book actually, I wonder, you could probably build it as like another layer on top of Yagi actually, right? Probably just encode like some sort of like have the order amend, like have some sort of broader contract that is a task on its own, right? And then people submit orders to that contract, and these orders modify the state, which then modifies the probe task, execute task. But it's basically like one big task that is connected to Yagi, and then people can post like smaller orders. So is the use here basically that this allows you to sort of like, I don't know, ask for like 5 executions rather than like continuous execution? Is that kind of how you use it?
Yeah, I think so. Yeah, I think that my game would expect 100 executions, 1 execution per an hour for the next 100 hours, and I can encapsulate this entire information into one order.
Yeah.
Well, I think ultimately it depends on the use cases, but I think that this seems compelling.
That's a great idea. Yeah, I think it can be built on as a wrapper. I think that like what is basically the DSL, right, with which you define these tasks, so you can make it just about timers in the beginning, but then make it more sophisticated. But yeah, it makes sense. Sorry, so.
No worries. I was just mentioning that this amplifies the MEV issue, where you possibly have them at 2 levels, one at the actual transaction running and the other one at the order book. So well, you probably also have it before the order book because you have to make a transaction to put something in the order book. So you have like three different layers of attack right there. It actually looks like that actually reminds me of like how cow swap or all the other MEV resistance, energy resistant exchanges try to mitigate this. Um, Maybe the easiest is to go like the flashbot ways, and it's just I am bribing you not to front run me.
Right. I think actually, yeah, that's another thing. By the way, when we do have flashbots, the keepers I think will directly submit to flashbots, and that's kind of how it works on L1 right now.
Mm.
Right now we have to go through these gas auctions, I think, in the short term. Yeah, I think with games, the good thing is there should be less MEV with games, right? Especially with, I guess, Guilty Gear, like in your applications of kind of physics, your kind of, I guess your puzzle is the only thing, the only benefit there is that your puzzle may compensate for the gas, and so there's no MEV. But I'm sure, like, yeah, as we get into kind of financial games and resource games, then a lot of MEV out there. Are there any kind of any other high-level primitives that you think can kind of make this easier to use, or kind of I like this order book primitive a lot. I'll have a think through it and see if we can offer it actually. Any other higher-level primitives that you think would help, or is kind of the broad kind of probe task execute task interface broadly fine?
I think that right now we have a web-based interface for registering bounties or registering tasks. Well, I think increasingly we'll move towards a reality where contracts themselves post bounty and basically ask for mothering. And I think in that case, so for example, I can have a game where there are multiple NPCs, and every NPCs upon sunrise will need basically 3 feeding, and so every NPC will trigger an order to Yagi saying I need 3 feeding over the next 3 hours, 1 per hour. And if the game contract is making these order posting, then the game needs to know that where Yagi is deployed, so that there's a constant address that's getting hard coded into all these games, and they can deterministically, so they are sure that when I make a function transaction to this this constant address, I know is Yagi on the other side.
Yeah, that's a good point because once you have the order book, you can use it in a like meta order book to say, okay, in the next, as you said, like in the next 3 hours, I will need that many transactions done. So that actually that might make it even more difficult for games. That's super powerful, but that makes it even more difficult for games to gauge how much they're gonna pay, or that could be, yeah, that's a bit tricky.
Well, you could still, I mean, you could still just have a fixed bid, right, in the order book.
Yeah. No, it's more. I was more mentioning like gas costs and stuff like this. Like whenever you're making scheduled transactions, that's that backend ledger, like the one thing that we had implemented. I was working on the ledger also. That's a B2B product, and it worked a little bit like Gnosis. Normal transactions, the way you do it is you craft it, you sign it, you send it. But for multi-sig wallets, what you do is you craft it, you approve it, then you send it. And in the little period of time during which you're approving something, the network conditions can change. It can change already when you're crafting sending, but it changes drastically when you wait an hour or so. So what we implemented was a max fee. Like how much am I willing to pay for this? And then we had like a clever algorithm which was like, okay, take the minimum of the max fee and the current network fee, but never go above the max fee because otherwise you're just going to blow up your fees.
Yeah, that makes sense. I've had the pain of yes, doing some sort of gas estimations for multi-sig transactions. It is tough. I think Starknet's like even tougher, right? Because we don't have the metering. So it is. I guess there is like a situation where even if you had this fully deterministic, the game could say, oh, I think I'm willing to compensate people like X amount, and then like I don't know, Starknet opcodes get repriced because like Ethereum opcodes get repriced. All of a sudden, that amount is like not enough to like incentivize, right? Or it's like less than the gas that it actually costs. Then I guess we may have to like over time build in some mechanism of like a variable fee, right? Which kind of replicates the margin. I think we have to build some sort of gas oracle or something into Yagi that that allows you to just say like, I want to pay 20% above gas that's estimated for this transaction, and that's it. I want to be just tied to that.
Yeah, exactly.
Yeah.
A random idea. I think that if you can make Yagi modular and generic enough, I think certain games with deep pocket on the developer side would want to fork Yagi and just deploy private Yagi for their own game, and where they will subsidize all transactions and they will have a more of a guarantee that their games will be sort of independent of the potential MEV stuff.
Yeah, that makes sense. Yeah, if you can run enough bots yourself, I guess and you really worry about MEV, that makes sense. I think it should be modular enough. I think the registry contract is going to be fairly lightweight. Just going to have all this kind of payment infrastructure that can be ripped out, and we have going to have a reference implementation for the bot. So I think this is definitely possible. Yeah.
I think it makes sense. Like I can definitely see a future where you have roll-up centric games. I don't know if I dreamt this or someone told me about that, but like Sora is thinking about like having their own roll-up on Starknet, and I think that definitely dovetails really nicely with what you just said, Gyoza.
Yeah, I think we're just beginning to scratch the surface of like, player, off-chain proofs, right, being fed into the rollup itself. And so that probably changes things around kind of state management and how we think about it right now.
I'm wondering how the whole automation thing will change once we have recaution. Like I'm not a dev. I don't exactly know how that's going to work out, but in my mind, it's like everything happens at the same time. Like you have n operations, and if everything is recursively computed, then you just have everything happening at the same time. So I wonder how big of an issue actually it's going to be.
Well, yeah, I think there's always some state that's only available at the time, at a later time, right? Like if you're pulling in external information or things like that. So, but yeah, I don't know.
Why is Yagi called Yagi?
Four-letter finance names. Yield aggregation and generation infrastructure is the kind of original name. Actually, the kind of original motivation was to start with vaults, but there was sort of no yield sources, and so kind of keepers were actually kind of a primitive that we could just build without any dependencies. So that's kind of why.
I see. Well, Yagi with his icon always gave me this vibe of NBA. That's kind of sport that.
Okay, I see that. Yeah, four-letter finance names, get them while you can, right? And data names. All right, well, we're coming up to the hour. I have not, no. So, yeah, this is awesome. A lot of great ideas here. And yeah, if you come up with any other ideas or have questions, reach out to me, and definitely, I'll hope to see many of you and answer them as well. I'll circulate this document today as well, so as to refer to it. And yeah, I think this workbook is really nice. So maybe that could be something I could actually draw for Matchbox, and so would love to talk to you guys more about like how that could look like and what a simple starting point could be. Yeah, and let me know if you need this for any other primitive as well. I see that Rodrigo's you've mentioned this a few times in Mint and follow that quite closely. And I think I'm trying to think of like if there's a puzzle idea around solving a sort of automation as well, where like people need to, I don't know, use Yagi to have a puzzle that where they need to like do something, I don't know, every hour for 24 hours, and sort of nobody would want to actually stay up to do it, and so they have to use Yagi or something like that. Still thinking about it. I'm sure some people would though. That would also be pretty cool.
If you want to like generate, that's what nouns does. Like every they've got a crafty system to avoid having to automate transactions. So every time someone buys the noun, it triggers the next noun auction. So rather than like link everything, we could link everything on the puzzles. Like once one puzzle is solved, it goes to the next one. But you could just have one minted every day.
I love it. Cool. Well, thanks everyone. This has been awesome. Yeah, we'll send an update on next steps here. But yeah, great stuff. And thanks Matchbox again for hosting. Sorry from the It's great.
And if everyone here, have any ideas for valuable workshops, DM me or Swag, and yeah, you can propose. Probably great, but
Yes. That'd be good.
anyone can suggest.
Yeah, and also I managed to record most of the calls, so I will share the video and you can share with whoever you in case of
Perfect.
need.
Thanks, Simon.
Awesome. Okay.
Awesome. Thank you, Peteris.
Thanks everyone. Have a good one. All right.
Bye bye.
Cheers.